Okay, so we're talking about decision trees, an approach for making a learning machine. We've had a couple examples. We looked at let's go back to that chart. So this was the example for classification for weather data. And now we're trying to look more in depth at how we're going to create this tree analytically and walking through those details. And so some of those information, some of the algorithmic information that we'll be using, be thinking about the gain ratio and also the Gini index. So ID3, which is a decision tree tool developed by Quinlan, makes the selection of partitions on the basis of the information gain or entropy reduction. So this is where we're getting into, instead of just doing it manually, we'd like to be doing it using computational means. C4.5 is a successor of ID3, uses the extension of information gain known as the gain ratio. And so here we have the gain information, and here we have the split, the gain ratio and the split info, how we would calculate those. So Gini is an example of a splitting criteria. And so the Gini index is used as a classification regression in classification regression trees, CARTs. We have this equation here for the Gini index, and where PQ is the probability that a tuplet in D belongs to the class YQ. So the Gini index considers a binary split for each attribute. It first considers a case where xj is continuous valued attribute having dj distinct values. It is common to take midpoint between each pair of the sorted adjacent values as a possible split point. The point giving the minimum Gini index for attributes xj forms of the split point. For a possible split point of xj, dl is the number of tuplets in D satisfying the split point, and d2 is the set of tuplets satisfying xj greater than or equal to the split point. The reduction in impurity that would be incurred by a binary split of xj is given here by the set of equations that we developed. And the attributes that maximize the reduction in impurity is selected as a splitting attribute. Then one of these two parts, D1, D2, is divided into a similar manner by choosing a variable again and a split value for the variable. This process is continued until we get pure leaf nodes. So that's those concepts. And now let's get a little bit more into the CART decision tree, the classification and regression trees. CARTs use a Gini index, and so we just talked about that, as an impurity measure, providing a general framework to produce different classifications in regression trees. The CART approach restricts the splits to binary values for both categories and continuous variable attributes. Thus, the CART decision tree is a binary tree. Here is another set of data. Here we have 24 households that we're evaluating, and we only have two features, the income and the lawn size, to then determine the ownership of whether they would have a lawn tractor or not. So here we have the tree stumps after the first split. And here we have a scatter plot after the first split. And so we see that this is not getting it completely done, although it is at least having a correlation to a certain amount. So that's good. So now we continue that process, and we have the tree stumps after the first three splits. And here we have the scatter plot after the first three splits. And so we're starting to get a little bit better. If the partitioning is continued till all the branches leaf nodes, each rectangle will have data points from just one of the two classes. And so that would be a good way of finishing that up. So the final concept we'll talk about here is pruning the tree. It's used to avoid overfitting in a decision tree learning. There's two main groups: pre-pruning, which is growing of the tree a stop before it reaches the point where it is perfectly classifies the training data, or post-pruning, the tree is allowed to grow to perfectly classify the training examples and then post-prune it down. The second approach of post-pruning overfit trees has been found to be more successful in practice. Okay, so that finishes our overview survey of decision trees, and we'll go ahead and leave it there for this lecture. Thank you very much.